everyone, and welcome back to the Edgeverse TechCast. This is the place you all go to learn more about NXP software, tools, and all the enablement that we provide. It's all for NXP processors and microcontrollers. I'm your co-host, Kyle Dando, and I am happy to announce we have Bridgette back. Glad you are here to help get this podcast back on track, Bridgette.
Wait, what did I miss while I was away, Kyle? I am happy to be back behind the mic. I had a challenging week, so I really appreciate you covering for me, and very happy to be back here. But I'm not the only one back. Our guest today was a guest back in the fall. He is here to help us cover a very popular topic.
Yeah.
Now, regarding today's topic, Kyle, here's something interesting to think about. Every second of every day, we rely on one of the biggest infrastructures ever built, and most of us never think about it. Any guesses?
Okay, wait. Are we going to expand the podcast to discuss topics like maybe the interstate highway of the U.S.?
Oh, so close, Kyle. But no, that's not it. What I was hoping you would guess was the power grid. And to help listeners better understand why, we have repeat guest Marcelo Marques back on the TechCast.
Hello, everyone, and thanks for inviting me. It's a pleasure to be back.
Marcelo, you work on the future of the power grid every day, and you're part of NXP's engineering and marketing team for the power and energy segment. So why don't you jump in and tell us a little bit about why we forget to think about this important grid that we rely on every day?
Sure, and you're correct. We never think about the grid. We actually take it completely for granted. We only think about it in two occasions. Can you guess which occasions they are?
I'm through
When
guessing.
my phone dies.
When you flick on the light switch and there is no power, that's number one. And the second one is when the bill shows up in your mail.
The bill. That one always makes me think about that silly grid.
Yeah, exactly. And neither of these are pleasant situations, right? Nobody likes to be in the dark, be out of power, and nobody likes to pay the electric bill. But behind that socket, there is a massive infrastructure, and it stays completely invisible to us right up until that moment fails. And today we're going to talk about how we can make it more reliable so you're never in the dark, and how can we make it cheaper as well.
All right, Marcelo, we've had lunch before and had conversations where you always bring up the phrase intelligent infrastructure. So are you saying that today's grid is not intelligent?
Not really. It's not that it's not intelligent, but that's a perfect question. Because to understand how this future intelligent infrastructure is going to look like, we need to understand how it works right at this moment in the present.
Okay, so how does it work then?
Well, it's complicated. So before I get there, let me tell you something that you need to know that it's fundamental and it's very important. Every unit of energy that is generated, they need to be consumed immediately because you do not store energy in wires. The energy has to constantly flow somewhere. So for example, if the demand goes up, you need to immediately, in real time, generate more power. If the demand drops, you have to produce less. Otherwise, the whole frequency and the whole system will collapse.
It's a giant balancing act that's happening in real time.
Yeah, that's a constant balancing act. And let me give you my favorite example and just how hard it is to make the system work. So let's think about soccer. Do you know that a soccer game is directly connected to the power grid? Think about the FIFA World Cup that we just had. Let me ask you this question. Who invented football or soccer? Do you know?
England.
Yeah, that's correct. So England, and you can bet that they love it. So when the England team is playing, the entire nation will stop everything they're doing to watch that game. And there is something else that they love to do. They love to drink their tea.
I think I see where this is going.
Yeah.
I have no idea. I have no idea where this is going.
Yeah, so let's just think about this. They love to make tea, and they use an electric kettle to make the tea. And that thing is power hungry. Have you ever tried to turn on the kettle and the microwave at the same time in your kitchen and you trip the circuit breaker?
Many times with a hairdryer.
Yeah, exactly. So picture this. Now you have England playing. The whole nation is glued to that TV screen. And then when the halftime whistle blows, everybody stands up, they go to the kitchen at exact the same time, and they switch on their electric kettles. That alone, and let me tell you, that alone is a 20% surge in demand. Just in a few minutes, one entire nation, in that minute, pushing the grid to the limit to make their tea.
And it doesn't crash?
Yeah, it doesn't. So the circuit breaker of England, if you will, doesn't crash. It doesn't even flinch. And that is where the magic is. There is an entire infrastructure behind the scenes and very smart engineers trying to predict the demand. They predict the habits of the people, the weather, everything. And they make sure that the power reserves are staged and ready to deploy the second that the referee blows that whistle. So there is a team of people in a control room, literally with a TV, watching the game, waiting for the halftime, ready to press buttons and deploy more energy in real time. Let me tell you something. That is arguably one of the hardest real-time problems in engineering.
Wait, so this sounds ideal for me. So there are people who who actually have a job to watch a sporting event and hit a button at a very specific time. That's awesome.
Yeah, so the short answer is yes, they are doing this. But of course, it's much more complex than just pushing the button. There's a lot of planning, and they are essentially doing their best to predict human behavior. And this is hard. It's like almost trying to predict the stock market.
Hmm.
Very good analogy. That's a beautiful system when it works. What happens when the prediction is wrong? And with the whole world racing towards renewables, is this getting easier or harder?
Well, let's think about when this intelligence fails, when you cannot predict the demand. Imagine, for example, that there is a heat wave and everyone turns on their air conditioner at the same time and the operators, they miss it. Or, for example, if it doesn't rain and all the farmers switch on their pumps to irrigate the crops. And if you're from India, that's probably ringing a bell.
Yeah, didn't they have this similar problem in India?
Yeah, exactly. Back in 2012, half of India went dark. It was roughly 500 million people without power for about 8 hours. It was the
Wow.
largest blackout in human history, in number of people affected, of course. That happened because this system or these people in the control room, they didn't fully account for the heat wave and the extra power needed in that afternoon, especially for the irrigation, brought the system down.
Wow. No, you're saying that's on the old grid, the one that you think is simpler.
Yeah, and that's the right point. So today the intelligence it's centralized, and that's why it's simple because power flows in one direction only. It's a one entity, a handful of power plants, the transmission lines, and they control how this is going to be distributed while predicting how the load is going to behave. It sounds simple, and in a way it is, and yet is arguably one of the most difficult real-time problems there is. And now that's where it gets harder, not easier. Most of our energy comes from fossil fuels, but we're quickly transitioning to renewables. Around the globe, lots of governments are fully committed to make that transition, and that transition will bring a lot of challenges.
I agree. Moving and transitioning to renewable energies is a fantastic idea.
Yeah, it is fantastic. Imagine you're going to have solar, wind, more energy storage with batteries. There are more things for us engineers to build. But here's the catch. You don't replace one big giant gigawatt power plant with one big solar panel. And even if you could, coal plants or fossil fuel plants, they run 24/7 hours a day, 7 days a week. A solar panel only works during the day and only when it's not cloudy. The same thing with wind turbines. You don't control when the wind is going to blow. So all these resources, they are not predictable and they are spread across the whole country where the weather isn't the same. The clouds move, the wind shifts direction and intensity. So it's getting really hard to predict and to plan and to coordinate these new sources of energy.
So renewables fix the carbon problem, but basically explode the complexity problem.
Exactly. And that's where the story gets really interesting.
All right, then try to help paint the picture for us for the future. If the old grid that you just talked about is unidirectional, what does the new one look like, and maybe where does AI come into that solution?
Well, let's make this personal and let me give you some more examples. So, for example, take our friend Deepak here in the office. He just told me that he put some solar panels in his house. He got an electric car with the bidirectional charging. He said he also put a battery pack in his garage. Sometimes he will buy energy from the grid, and sometimes he will sell energy back to the grid. He has an intelligent thermostat inside his house that figures out the optimal time to buy from the grid and to sell back, to charge the car, and to even sell energy from the car back to the grid. So Deepak is basically becoming this small power plant and consumer at the same time, but you do not predict when he's going to do it.
All from his own house. That's awesome.
Yeah, all from his own house, and all because he just wants to avoid being in the dark and paying the electric bill that we just talked about. And it's not only Deepak. Maybe you and Bridgette will do that too. Like the NXP office is doing the same. We're going to have bidirectional chargers in the parking lot, solar panels in the roof, a big battery storage. Think about it. Multiply that across countless homes, buildings, factories, hospitals, etc. Can you see the complexity?
Yeah.
We are no longer decentralized one directional flow of power. It starts to look more like a matrix with distributed resources. And we call this a microgrid.
The matrix. I love the matrix, but that brings in a whole different kind of problem with math, right?
Yeah, so matrix calculation, no linear problems. There's a really good thing to solve this, which we know it's AI, machine learning. Just to make things more interesting, let's add to this whole picture data centers. And not just only a small data center, but gigawatt data centers that consume as much power as an entire city, which have their own power plants. They have their own solar, they have their own battery storage, and some of them even have a dedicated nuclear power plant. They will be bidirectional too. So they will be part of this matrix. So we are at this turning point. We're moving from the traditional grid to the future, from centralized to distributed. There won't be a central entity, for example, watching the World Cup and waiting for the halftime whistle. It will be autonomous, agentic, intelligent, and all interconnected. Imagine from Deepak's solar panels, his EV charger, his meter, and his HVAC system, all the way up to the NXP office parking lot, right down to the coffee machine. All these elements interconnected, deciding where energy will flow.
So it's great that the coffee machine, where everybody gets together, is part of the national grid problem. That's crazy. But you know what? You did a great job. I can actually see the picture you're painting there.
Yeah, and that's exactly where the challenges begin.
So, if you're building this future, what are the three biggest engineering challenges you see?
So picture all these devices, each one with their own AI agent, making decisions about how to optimize energy, all coordinating with each other in a house, in a building, in a factory, across the whole city. That raises four big challenges. The first is the real-time intelligence. These devices, they need to make decisions locally in real time. Do they send everything up to the cloud to be processed in a data center, or is it more cost effective to decide locally? One thing is going to matter enormously in the future: the cost of intelligence. In other words, the cost per token. Today, we track, for example, the price of the barrel of oil very closely. Don't be surprised if in the near future we start talking about the cost of a token. Once you think that way, bringing these decisions to the edge becomes a no-brainer.
Okay, so that's the first challenge. I asked for three. You're going to give me four. So, we got a bonus challenge. So, I'm excited to hear about that. So, what's next?
The second one is the security. Picture all these devices in this matrix, part of a critical infrastructure, and the last thing you want is a cyber attack on it that can take down a house, a building, or the whole city. The third one is the interoperability. All these devices distributed, they have to connect, communicate, and coordinate constantly in real time. And the fourth one is functional safety, because when these devices fail, they have to fail safely. You can't have batteries catching on fire inside a hospital or high voltage in the chassis of your EV charger. So safety has to be built from the ground up.
Four very different but equally important problems to solve all at once.
Yeah, four very different problems, and they all have to be solved together.
Let's tie it all together, Marcelo. Where does NXP fit into all of these solutions that are required? Then leave us with a picture you want people to remember about how we put this together.
Yeah, so this is exactly where NXP shines, because those four challenges map directly into our portfolio. We have this broad range of microcontrollers, microprocessors, AI accelerators, and discrete neural processing units, analog, connectivity, all designed from the ground up to enable AI at the edge. To be secure, with a secure enclave and post-quantum cryptography ready. To be interoperable, we have Wi-Fi, Bluetooth, Ethernet, UWB, NFC, and we enable all this with Matter. Now, to be functionally safe, we have certified designs with all safety mechanisms, diagnostics built in at the hardware level, in the drivers and in the software, not just at the part level, but at the system level as well. And speaking of systems, we have a complete solutions for every one of the segments: power meters, flow meters, power conversion, energy storage, and for both residential and industrial, EV chargers, home and building automation, and data centers.
Okay, you've listed a lot of things there, and I agree. Being an NXP employee, it's impressive. We definitely have the solutions. But I heard you have a demo that you've shared with customers that ties this whole vision together. It's a little easier for customers to understand where we fit. Can you describe that a little bit?
Yeah, we do, and we showed that at CES last year, and it captures this future beautifully. The demo is about a whole microgrid. Picture this. You have a building with a parking lot, some cars, energy storage, solar panels. And imagine you drive to work in your electric car. When you park, you plug the car in. So there is an AI agent in your car that starts talking to an AI agent on your phone. And it checks your calendar, it knows your habits, and it figures out how long you're going to be parked, where you're going to go next, how much battery you need, and the best way to charge your car given the battery chemistry and the temperature and some other parameters. Then the car talks to the building agent, which checks the weather, the solar intensity, how much the solars are generating, how much battery you have in the storage for the building, what is the price fluctuation of the energy throughout the day, and it plans for your car the best charging profile for that day. All these agents, they coordinate to build the best possible plan, not only for the building, but for your car. Now expand that to every car in a parking lot, to every building in a neighborhood, to the whole city, and to every appliance in your home. Everything taking part in this one matrix of distributed intelligence, all orchestrating to save every last bit of energy. So the demo travels around the globe to NXP events like Tech Days. So please come to see it if you have had a chance.
Oh, that's great. So I'm going to be at a few of the tech days. I'll definitely make sure I go check out this demo. It definitely is impressive. All the AI agents and the coordination and how it's going to optimize how we consume energy off of the grid. That's perfect.
Yeah, and just food for thought. Think about the electric kettle that we mentioned at the beginning. Do you think that in the future, that kettle is going to be smart enough to be part of the grid as well? To start boiling the water slowly just before the halftime and help to not overload the grid? I
Yeah.
think this is the future, and we shouldn't only dream about it. We should go ahead and build it.
That's a picture of the future I will not forget. And to our listeners, next time you flick a switch or put the kettle on, maybe spare a thought for everything working invisibly behind it. Marcelo, thanks so much for being with us today.
Thank you so much. It was my pleasure.
Yeah, thanks, Marcelo, for joining and educating both me and the listeners. I think Bridgette knew everything you covered, but it was great for me.
Maybe just a little bit more than you, Kyle, but that's only because I helped Marcelo on both the CES demo and some of his presentations at the keynotes at the tech days around the.
Well, that you're extremely sharp, but all right.
Oh,
well, okay. So for those listening, we appreciate you taking the time. And if you enjoyed this conversation, remember, tell all your coworkers, tell your family that you learned a little something new about the electric grid and about technology in general. After that, make sure you subscribe, you like this video. That'll definitely help Bridgette and I get more followers and help us bring more education to you in the future.
And until next time, keep innovating, look forward to the intelligent grid, and we'll catch you on the next Edgeverse TechCast.